little bit more of a deep dive into how FDO works. So please welcome Geoffrey Cooper, who is a principal engineer for IoTG at Intel. Geoffrey, welcome.
Hi, everyone. Hi, I'm the co-chair of the IoT Technical Working Group. And I guess if I share my screen now, we'll be able to start seeing my presentation. That looks like it's working here. Okay. Um, I'd like to tell you a little bit about how FDO works. So now we're going to go a little bit deeper into the technology and take it as we go. We'll go gradually and we'll sort of describe things. So here's what Richard told you about FDO, what FDO is capable of doing. So we have here a device, and we're sending it um, from the factory or from the distributor all the way to its target location directly. And then we're going to turn it on, connect it to the network, and then the device is going to provision, it's going to do everything it has to do so that it's just in service running. And the person who's standing beside the device doesn't have to log in, doesn't have to type a password, etc. And so this is what we mean by all these things: fast, secure. We run in different kinds of networks. We run in a closed network. That's a little bit interesting, and that's something that will often come up later in your deployment. You might say, "Oh, I'm only going to go to the internet," and then some customer comes along and says, "No, this is a closed network. I can't get to the internet." FDO will stand by you. Wide variety of processors will work with FDO. So if you have smaller computers that are IoT type devices that are headless, or you go all the way up to a server that's headless, FDO will help you to manage this headless device easily. And we have multiple vendor implementations, and this is something that FIDO has been instrumental in putting together. So let me tell you a little bit about how it works. So we start off in a factory. And we're building we're building a device, an IoT device, for example, or some other kind of device, and we've decided we're going to supply it with FDO. So then what we do is we have an FDO tool in manufacturing, which will put some particular credentials into the device. So here we have an FDO client. Here, I'll try moving over here. I'll be a little bit more precise. Here we have an FDO client. We have credentials to it. There are some certificates, etc. And then we have a path to something called a rendezvous server. And so we'll choose a rendezvous server and put its address into the device. Now, what we haven't put into the device yet is we haven't put in the device of the cloud, the name of the cloud that's actually going to onboard the device yet. And this rendezvous server is going to take the place of that in the manufacturing process. And that's going to allow us to have any device and any cloud onboard your device. And what's going to determine that is this ticket to onboarding here called an ownership voucher. So we have the device goes into a box, it's going to get shipped out, and the ownership voucher goes across the supply chain to the target cloud who's actually going to onboard the device. And that could be a multi-step process, or it could be that the target cloud just is the guy who ordered it and it gets sent to him. How does it get sent to him? Could be sent in an email. It's a self-securing object. Only the target cloud can use it. And then the target cloud will now take that and it will send it to that rendezvous server. So remember, we put that rendezvous server URL into the device. And now the owner will say, "Oh, I have an ownership voucher for this device." And it does a little bit of proof and that sort of thing. That's the kind of thing we do in the protocol world, so that the rendezvous server can vouch for it. And now the rendezvous server knows that this target cloud, here's an IP address of an FDO owner that says, "Hey, I'm ready to onboard this device." Okay, next step. At some point, maybe it's 3 weeks later, 4 weeks later, the device actually gets installed. The cloud has been waiting all this time. The rendezvous server has been waiting all this time. The device comes up, and I've sort of put a star on it to show that the power light went on. And so now the device has network connectivity. And the first thing it's going to do is it knows that rendezvous server. So it's going to go to the rendezvous server and it'll say, I have information about myself. I'll give you my credentials and I'll say, "Do you have an ownership voucher that corresponds to me? And if so, who sent it to you?" And what he'll get back, so he's not sending any critical data, he's not offering to give himself to be controlled remotely, etc. All he's saying is, I'm this device. Did somebody come along and say, I've got an ownership voucher for this device? If he does, he'll get an IP address. And with the IP address, he can reach up. And in step 7, we're actually doing the onboarding. And that's where we actually apply all of the crypto credentials. So the device will sign a challenge. This is the way we describe this. The device will sign a challenge. The target cloud will look at the device certificate, which is inside of the ownership voucher, and will verify that this is really the device that I'm talking to. And then the target cloud will sign the ownership voucher and send it to the device. And the device will use that to verify that this is indeed the correct target cloud that has the ownership voucher. And then with 2 signatures, you get what's called a key exchange. These are all crypto tricks that we apply, and that allows you to create a secure channel. And then with a secure channel, we'll start these things called FSIMs, and these are sub-protocols that actually allow you to access all the functions on the device. So one of the FSIMs might be for transferring a file into the device. Another one might be for sending a log file back to the server. Another one might be for running a shell command. And you can extend the FSIMs if you have special hardware. And that's sort of one of the features of FDO. And so we've done all this work. Okay, what have we accomplished? Well, if we've done the right thing, we now have the ability to put all the information in the device, all the information in the target cloud, so that when we're done with FDO, the device is in service. So I don't mean that the device can talk to the cloud and that somebody at the cloud can spend an hour getting the device ready. And I don't mean that somebody is standing beside the device spending an hour ready. No, the device is running in its final configuration as part of your solution. And this is the way in which you can have a group of devices, and you can go by them all, turn them on, and FDO will just run in background, and all the devices will come onto the network. So here's the whole solution. I guess this is what you would call a complicated diagram, but we've sort of gone through it a little bit by bit, and you can kind of see that all the work is happening over here in this piece, and the rest of it is to give you the flexibility that you need to have. Now, FDO implements a late binding concept, and one of the things that we can see happening is sometimes we have devices that are sent to different customer ecosystems. So it might be that a given customer has a certain kind of a certificate that they need, or they might have a special kind of a hardware device, so they need a driver for that hardware device. But essentially, both customers, say customers 1, 2, and 3, are all getting the same device. So but they have certain characteristics of the software that need to be different. So the manufacturer is out there creating 3 different SKUs for the device. They're putting, say, one kind of certificate in purple devices. They're putting a different kind of certificate in the orange devices, and yet another kind of certificate in the red devices. Or it might be that the red devices have a certificate and a driver for some special hardware that they're going to get plugged into, say, on the USB port. Okay. Now, FDO does another thing, right? FDO says that in FDO we can do this differentiation. And why is that interesting? That's interesting because instead of building to order, we can build to plan. So we can say, hey, I've got one device and it can support all kinds of different applications, and it does FDO. And when this device arrives at the customer site, the device then takes on the characteristics, the certificates or the software or the drivers that the customer environment requires. And that can be programmed either directly by the customer or by a VAR, and so that the customer is able to adopt the device, a standard device. And we sort of describe here that the customer, that FDO is kind of painting the device in the customer's color. So I excuse this weird painted arrow here, but that's what we're trying to illustrate. Now, let's talk a little bit about security. And without going too deep into it, there are some security features that are built into security devices. So we might have secure boot that prevents a device from booting unless it boots this particular software that you've chosen for it. There might be security measurement, which checks to see if the BIOS or the operating system has been modified by someone during the device. These are features that are often put into the operating environment of a device. And FDO adds on to these by adding in this zero trust with attestation. Zero trust means that you have to prove yourself every step of the way. And we'll go into that a little bit later in my last talk. But the zero trust is a point where FDO is going to do what's referred to as attestation. That's the digital signature part. And it's going to do it in both directions, right? So we talked about that with the ownership voucher. That's actually implementing your zero trust. We have this extensible mechanism for doing operations. So if when you start working with your application, you have a certain set of operations, you can add to them over time. In fact, some of these security measures may be operations that you would like to do during your onboarding. So maybe FDO, which does certain sets of attestation, doesn't do enough measurement for you. Maybe you'd like to have your FSIM that goes and reaches over to the security measurement. Okay. And so this allows you to get to the point where FDO is getting you to a completely secured environment where all the different pieces are operating together. And this is what the extensible FSIM mechanism gives you at FDO. Now let's talk again about zero trust. So zero trust, never trust, always verify. Every time you're going to take an action, you have to always prove who you are, and you have to prove that the person you're talking to is the one you expect it to be. And we've seen that the ownership voucher allows trust to be established in both ways, device to owner and owner to device. And this is zero trust. So why do we have an ownership voucher? Why don't we just send a device certificate? Or why don't we just trust the device anyway because we've got maybe a token for that device? Well, because we need to have the owner verified to the device so that we're following the zero trust model. Okay. So what is this ownership voucher? Well, the ownership voucher is a special data structure that has cryptography built into it. And it has different ways of applying it. Now, if you're running a single cloud, which is onboarding all of your devices, the ownership voucher, there's just one cloud for all of the ownership vouchers. And in a multi-cloud environment, so that single cloud environment, let's say that again, there's only one place to send all of the ownership vouchers. So what does the factory do? The devices go the way they go today. They go into the supply chain. They could go through 5 or 6 different steps in the supply chain. The ownership vouchers all go to the same place. They all go to a cloud. So there's just one connection to get all those ownership vouchers across. Say you have multiple clouds, right? So then some of the orders will say, I'm going to be servicing this guy in Europe. Some of the orders will say, I'm going to be servicing this guy in North America. So you might have ownership vouchers being sent to the different sites. And I'll show you how that works a little bit later. And then magically, the devices will get onboarded in the right place, right? So if, say, you have a government regulation that the server has to be in a particular country if the device is in a particular country, then you might get an order that says, I have to send this to the server that's in this particular country. Well, in that case, you can do that. You just send the ownership vouchers in that place. How do you know to send them there? Because the customer told you to do that when he ordered the device. Okay. And if you go to multi-tenant, if you get in that situation where you have different tenants that are coming in, do you have to have each tenant on board by itself and have them all track their ownership vouchers? No, you can actually put the tenant identifier into the order, and then the manufacturer can put the tenant identifier into the ownership voucher. So then the devices can all onboard into one place. And then we take a look at the ownership voucher, the device can see it and the owner can see it and says, oh, okay, which tenant is that? And then we'll just route the device to the correct tenant. Okay, so the ownership voucher is sort of a new thing, and new things are always a little bit suspect, a little bit nerve-wracking. But we think it's something that's really going to help you. Think of it as the ticket for onboarding your device to the cloud in exactly the way you want to onboard it. There are some other techniques for onboarding that are out there. There are some other standards. There are 2 standards from the IETF. One is referred to as Bruschi. I'll pronounce it that way. And another one is SCTP. And people often ask, how do they compare? And all 3 of these are excellent mechanisms. They have different characteristics. And you may discover that what we believe is that FDO is the one that is the extensible mechanism that will last with you for the longest time. And let me explain why that would be so. So all of them follow this zero touch approach. But when we get to zero trust, Bruschi has signatures in one direction, and then the verification of the platform is actually based on this idea of a manufacturer authorized signing authority. And what that means is it's not actually written into the Bruschi specification. So whether you do it properly or you don't do it properly depends on your actual implementation. So they're leaving you to do that. SETP, good zero trust. Internet devices, yes, you can do that in all of the mechanisms. If you're in a closed network, again, you've got this massa that's deciding what to do. The massa will be different in a closed network from in the internet. So that means that Bruschi will actually operate differently in that situation. So think of it as really Bruschi A and Bruschi B that you'll have to go and figure out what you're doing. So it's not really taking you into that closed network the way, say, FDO would do and the way also SETP would do, but it's saying that you have to actually change it, okay? Flexibility of onboarding. Bruschi actually doesn't finish the task. What it says is, here's how you get a certificate in two directions. Then you run a connection and then do whichever you want to do. And that may be exactly what you want in your solution. So if that's what you want, this is a good way of going. If you don't want to go and deal with the frameworks that we give you in FDO, Bruschi will give you an option to figure out how to get that first connection and nothing else. In SETP, you can specify specific files that are going to get downloaded. Some of the files would get, say, would be intended to be booted up and update the software. And some of the files might be data files, okay? And often that's what you're doing for FDO. So SETP is a pretty good mechanism, but the thing that FDO does is it actually has this FSIM mechanism that's actually a multi-pass mechanism. So if you say, well, you know, I designed this thing and now I need to go and add an extra security check, or I added this device, this card that's in some of my systems, and so I have to have a pass after I log in, after I set everything up to go see if that card is there and go do something special for that card. FDO will let you go and extend your onboarding mechanism to include multiple passes saying, oh, do I have that card? Now, if I have that card, let's see what I do, etc. The conversation is more complex. And because of that, FDO applies to a lot of different target applications. And we have people who are looking at all these things. So edge is sort of the basic idea of being outside of the data center. And IoT is sort of that. Sometimes people think of IoT devices as smaller devices, but certainly headless devices. But if you take different, as Richard was saying, if you look in different areas of industrial, medical, automotive, retail, I think that there are actually really good applications for FDO in all these areas. Now, Bruschi was designed for IoT, makes a lot of sense in that area. SETP was designed for routers and connectivity type devices, makes a lot of sense in that area. And you can kind of see that the flexibility of onboarding kind of matches the area in which the device, in which the scheme was set up. So just to sum up here, FDO is a very, very flexible mechanism, and it allows solution providers to choose the architecture that meets their needs. And of course, why is that important? Because your solution when you started off is going to be simple and you understand it. Because why would you do it if you didn't understand it, right? But if you were able to jump into the future and look at what you ended up with, it's going to be a lot more complicated than that. All of our human endeavors start with simple things, and they start with a single cloud, they go to multi-cloud, they go to closed networks, they start with a cloud service, they go multi-tenant. We always start with something simple and then we build up on it, and that's what we do, right? That's how we develop all of these things. And the thing is that FDO will stick with you. So we encourage you to use FDO, to learn about it, and I thank you for your time, and that's basically what I had to say to you. And here's where you can download the specifications for FDO. It's up on the FIDOalliance.org website. Thanks very much.
Oh, my mirror's here. Hello. Jeff, thank you
Hey,
so
Megan.
much for that overview. I didn't see any questions come in. If anyone has any questions, we may have a minute to ask Geoffrey a few questions. I didn't spy any in so that must mean that you explained everything perfectly and no one has any
Everybody
questions.
understood
It's a
everything. It's
wonderful
such a
thing.
simple protocol.
Oh, there is a question. Is there any global ledger that records all the ownership vouchers that are issued during the whole journey of the device in the supply chain?
That's a really good thing. Good point. The interesting thing is we didn't feel that we could scale, that we could build something that would scale to global levels. The right way to do this is a distributed solution. So the answer is no. You get to decide where the ownership voucher goes for your devices. Now, could you build a global ledger of all the devices that you published as a manufacturer? Yes, you could do that. And maybe you could use that to support some of your customers. But there's no way in the world of actually seeing all the ownership vouchers in the world. That would be a security vulnerability. And by the way, after you onboard a device, the ownership voucher has no control over that device. You actually get a new ownership voucher when you onboard the device so that you can use FDO again, and only you have that copy of the ownership voucher.
Thank you, Jeffrey. Think I think that will do it on questions. So thank you so much for your time. You're coming back a little later, right?
I will, yes. Can't
Okay,
wait.
great. So we'll see you in a little bit. Thank you so much, Jeff.